compute the derivative of x squared minus 8x times e to the 2x. Now, these are examples where you need the product rule and the chain rule, or maybe the quotient rule, all put together. So it's kind of complicated. Alright, so here you have this function and another function. So it's important to kind of see the overall picture of the function. If you call this like f of x, and if you call this g of x, it really looks like fx times g of x, right? Now if you can make this function look like this, then of course you can use the product rule, which is f prime of x times g of x plus f of x times g prime of x, right? So we have x squared minus 8x prime, the first thing gets differentiated, e to the 2x has to wait its turn, plus x squared minus 8x times e to the 2x prime. So that's the derivative. And at this point, we didn't even care about the fact that 2x is nested inside the e to the x, right? See, e to the 2x is like a nested function, because if you bring this x over here and cover it, that's like what? That's e to the x, right? So you can indeed see that that's a nested function. But we didn't care so far because we were still able to write down this prime. Okay? And that's the beauty of solving a question step by step. If you try to write the answer right away, it becomes a very hard question. But if you just think about how you can break this big question into a series of small steps, then it becomes easier, right? So we first identify that this looks like product of two functions, so I just merely wrote down the product rule. And let's just see if it can work. X squared minus 8x prime, that's easy. X squared differentiates to 2x, x differentiates to 1, so it's this. Now, it's at this stage when you see that you have to differentiate e to the 2x that you need to use the product rule. No, not the product, the chain rule, because 2x is nested. So we cover this 2x as x, and now I see e to the x as the function, and the derivative of e to the x is e to the x, right? But what is this thing we covered? That's 2x, right? And then we make a copy of the 2x and we differentiate, and therefore we get 2x minus 8 e to the 2x plus x squared minus 8x 2 times e to the 2x. That's 2 times e to the 2x. Okay? Now, let's see. These are all, they both have e to the 2x, so let's simplify by factoring the e to the 2x out. You get 2x minus 8 left, and you get 2 times x squared minus 8x left, so this is 2x squared minus 16x, and I can see that 2x and negative 16x are like terms, so I put them together, so you get 2x squared minus 14x minus 8 e to the 2x as the simplified answer. Okay, next. Alright, so we have a bunch of things, and we're trying to differentiate this. 4 e to the 3x minus 7 times e to the x over x plus e to the 8 prime. Well, because these are minuses and pluses, in that case we just simply differentiate each individual ones separately, right? Dealing with addition and subtraction for derivatives, that's easy, okay? It says these questions. Oh, and by the way, another reason you want to write this intermediate step is because when you do this on the exam, by just writing this, you've already started getting partial credit. So this is really getting 1 point as partial credit. And that's a start, right? Oh, we have e to the 3x. We just differentiate e to the 2x, so it's very similar. So what you need to do is you take this x and cover that and think of it as e to the x. E to the x differentiates as e to the x. Oops, that's not what I want. So e to the x differentiates as e to the x, but that thing that we covered as x is really 3x, right? Whatever you covered, you bring it outside, you differentiate, right? Okay, what about this? Well, this is a quotient, right? So you have to use the quotient rule. Differentiate. The top gets differentiated first. The bottom one has to wait its turn. So in the next step, it gets differentiated, right? And then the bottom has to be squared. Okay, what about e to the 8? Well, e is a number, 2.7 something, and you take the 8th power of it, that's also a number. So this is just a number. It doesn't have any x in there. So the rule of thumb is, if you're trying to differentiate by x and you don't see an x, what does that mean? It means that even if you change the value of x, this is not going to change its value. So it's a constant function, which means the derivative is 0. Okay? Now, if you're still not convinced, and you really insist on using some kind of rule like the chain rule, I don't really advocate for that, but for some of you who really want to see it, I'll still show you how to do this by the chain rule. So if you use the chain rule on this, you can think of 8 as the nested function, right? So think of it like this. Well, the derivative of e to the x is e to the x, right? So you get the same thing, e to the 8, because x is covering 8. But then whatever you covered has to be brought outside, and you have to differentiate. But what is 8 prime? 8 is a constant, so if you differentiate, 0. So it's e to the 8 times 0, which is 0. So that's another way to argue that this will give you 0, but that's just too much waste of time. You should be able to just see this, and I don't see an x, immediately the derivative should be 0, okay? Alright, so we have 3x prime, which is 3. 3 times 4 is 12. And then we have this horrible thing, e to the x prime is e to the x. Usually you write down the polynomial first, so I'm going to write it as x times e to the x. X prime is just 1, and it's over x squared. And this is so messy that there's really no way to simplify it, but if you really, really want to simplify it, you can take this and factor the e to the x out, because that's the common factor. So maybe we can write it as 12 e to the 3x minus 7 x minus 1 times e to the x over x squared, but that's the most you can do. Okay, compute the derivative of this. Oh, this time the inside function is quite large. It's this thing, right? Oh, right, so let me shrink this a little bit, make it flat. Alright, that looks better. Okay, so e to the x power. So compute the derivative of e to the x power. E to the x derivative is e to the x, right? So you can just say the derivative of e to the 2x plus 3 ln of x is the same thing. But wait, this is the thing that you covered, so when you uncover it, that uncovered part has to be copied and multiplied and then differentiated, okay? I've seen many people forgetting that this is a multiplication. It's a multiplication, okay? Some people write this as an addition. Don't do that. Okay, and then 2x differentiates to 2. Log of x differentiates to 1 over x. So that's what we get. Now, actually, you know what? There's a better way to solve this, and that's if you know all these log rules, you can simplify it. So first you can break up this exponential into 2, e to the 2x times e to the 3 ln of x, And it's easy to see that these two are the same because they have the same base. When you multiply two exponents of the same base, the exponents add up, so that these two are exactly the same. So going this way, you can easily see that's true. But in math, if A is equal to B, then B must equal to A also. So that's why this is true. And then we can further simplify this by moving this up here. You can make 3 hop over the log, and then that's e to the 2x e to the ln of x cubed. And once you do that, you remember that e and ln cancels, right? So you end up with this formula x cubed e to the 2x. So this really is same thing as x cubed e to the 2x, believe it or not, okay? And therefore, if we differentiate this, that's just the product rule. X cubed prime e to the 2x plus x cubed times e to the 2x prime. And x cubed is 3x squared e to the 2x plus x cubed. This is e to the 2x. You're covering 2x. Uncover that and multiply by the derivative of the inside function. And that's 2x cubed. So it's 3x squared plus 2x cubed e to the 2x. And this looks nothing like this, but indeed if you simplify this in this way, then you'll see that this is indeed the same thing as that one, okay? So I would say this is the simplified one, but you know, in the exam, if you did this and you didn't know how to simplify, you'll probably still be given full credit. Alright, last question here. Oh, fraction. That's quotient rule. Horrible, horrible. Oh, but thankfully it says do not simplify algebraically, and actually some of my exams will say that. I'll put a question about the derivative and say do not simplify algebraically. Alright, so let's try to differentiate this. It's the quotient rule. The numerator gets to be differentiated first, and the denominator has to wait its turn. Minus x squared minus 5x times e to the x squared plus 5x prime over e to the x squared plus 5x squared. Okay. Now this part, that's easy to differentiate. That's 2x minus 5 minus x squared minus 5x. And this one here, it's really this e to the x squared that requires the chain rule. So what we can do is we can bring this x to cover this part. So it's e to the x. If you differentiate e to the x, that's e to the x. So the derivative of this is e to the x squared times, you make a copy of that thing that you covered, copy of the inside function, differentiate, and that's 2x e to the x squared. So that's the derivative. Once you know that, that would be 2x e to the x squared. Derivative of 5x is just 5. And you have this thing. Looks very horrible, but because the question said you don't have to simplify algebraically, this is how you leave it.